Commutative property of addition. Okay, well, the concept of commutative property comes from basically the keyword commute. So if we speak about commuting, we talk about that idea of what does it mean to commute? It basically means to move items around. So if I commute from one city to the other for work, that means I'm moving from one back to the other. So I'm kind of moving back and forth. So if I commute in math, what that means is we're allowed to now move items around. So that, again, helps us simplify a problem. So the basic concept says if I have A plus B, that would be exactly the same as if I have B plus A. I can commute those, I can move them around, and it sometimes will help us simplify a problem. So let's look at an example of what this looks like. So let's see a basic initial problem to solve. Let's start off with one that says, what about 5 plus 7 plus 15? Now we're trying to figure out how do we put these together, like which numbers would be the easiest to add. Do I add those two? 5 plus 7, pretty basic, gives us 12. But then we've got a little bit more complex number where we've now got to add on the 15. Do I add the 7 and the 15 first, which gives me 22, and then I add on the 5? Or would it be better to go ahead and take this number here and put it next to that number? Well, that's the approach we're going to use with this commutative properties. I'm going to say, you know what, I think it would be easier if I took the 7 and I moved it, I switched positions with the 5, and I continue with my regular number. So all I did basically is I took this 5 and this 7 and we commuted them. We moved them to a new position. What does that allow us to do? Well, 7 plus 20, because now we've got the 5 plus the 15, now gives us a simple answer of 27. So by moving these around, we're able to simplify the math problem a little bit more. Now again, this is a pretty simple example of it. But what we're looking for is how do we use this for more advanced problems? Well, if we look at a more advanced problem in math, number 2, what we're really looking at then here is maybe something like, if we still consider a solved problem, maybe I had something like 1/3 plus 5 plus 2/3. So now I can either add these together and get fractional 5 and 1/3 and then add on 2/3, or I could again identify that these two numbers here, if they were next to each other, could make this problem a lot easier. So let's move those so we see what that looks like. So I'm going to take the 1/3 and I'm going to switch it so that the 2/3 is next to it. Now, some of you are probably trying to figure out which way we could do this. Remember, it does not make a difference. I could have done this, 5 plus 1/3 plus 2/3. So I could have either left the 2/3 alone, or I could have left the 1/3 alone. Either way, I'm only moving two of the numbers. I'm switching positions basically to make this problem a little bit easier. Now if I look at the problem, what do I have? Well, 1/3 plus 2/3 is 3/3 or a whole, which means my final answer comes out to be 6. Okay, you'll sometimes also see this same exact type of problem, only it might be something like this, where rather than solve, we're asking you to simplify. And it may have something like 2x plus 3 plus 5x. And it'll want us to simplify. Okay, well, by rearranging, again, by moving two of these numbers, whichever two we decide to switch, we can then go ahead and change this so that our problem reads 2x plus 5x plus 3 or 7x plus 3. Again, it does not have to be, and I want to just make sure that you understand, it does not have to be just two numbers. Okay, so let me show you an example of what I'm talking about for that one, and then we'll wrap up this little session here. So what if I asked you to do something like this? Solve 5 plus 3 plus 15 plus 7. Okay, trying to solve that. I'm looking at these numbers. I see, in my head, I can kind of see that 5 and 15 would really go together well if I could put those together, because they're both digits of 5, right? And I could also kind of see that, what's 7 and 3? Well, that gives me a 10. So if I could kind of rearrange a little bit, I could rewrite this as 5 plus 15 plus 3 plus 7. I could move things around, rearrange some, and now I could get 20 plus 10, which would give me 30 as an answer. So this whole idea of commutative property allows us to rearrange, to move items, to make things simpler.